Hello and welcome to the channel. Here we have an interesting average speed problem, the type of which can fool people if only trivial thought is given. It also highlights some misconceptions about average speed when applied to a typical journey. A car ascends a hill for 2 miles at a constant speed of 20 miles an hour. It then descends for another 2 miles. At what speed must it descend in order to achieve an overall average speed of 40 miles an hour for the trip? If you wish to give it a try, then please pause the video. Some of you will have figured it out without any calculations, and we will discuss that later. Others may have intuitively thought that the speed of descent required is 60 miles an hour, because 40 miles an hour is the simple average of 20 and 60 miles an hour. However, it is incorrect to take a simple average of the speed just because the two legs of the trips are the same distance. As the overall average speed depends on the sum of the durations of each leg of the trip, the only way to average speeds is to use a weighted average based on duration. Now the time taken for the ascent is given by distance over speed, or 2 miles divided by 20 miles an hour, which gives us 1/10 of an hour, or 6 minutes. By the way, for those of you who are not technically minded, the best way to remember equations is to look at the units of any quantity. As speed is usually expressed in miles or kilometers per hour, then speed is clearly distance divided by time. Now the total time required to achieve an average speed of 40 miles an hour is equal to the total distance over the average speed, and is equal to 4 miles divided by 40 miles an hour, or 1/10 of an hour, or 6 minutes. But there's a big problem. We have already taken 6 minutes to go up the hill. Thus we would need to go at an infinite speed in order to achieve an overall average of 40 miles an hour. This is clearly impossible. Of course, we could have arrived at this answer without any calculations. The time taken to go 2 miles at 20 miles an hour is the same as the time taken to go 4 miles at 40 miles an hour. Therefore, there would be no time left to complete the second leg of the trip. Even if we did 100 miles an hour down the hill, we would only achieve an overall average of 33.3 miles an hour. In fact, the overall average approaches 40 miles an hour as the descent speed approaches infinity. We can see this more clearly by having a quick look at the fairly straightforward mathematical expressions involved. Here we have an equation for the average speed, v0, in terms of the v1 and v2, the ascent and descent speeds, over 2 equal distances. If you know a bit of algebra, you can easily derive this using the basic distance times speed equation. If the distances were unequal and were, say, d1 and d2, then you would simply have a d1 and d2 in the equations. If we plug in the numbers 20 miles an hour and 100 miles an hour from our earlier example, we get the average of 33.3 miles an hour. It can be seen that the denominator is the sum of the reciprocals of the individual speeds. Thus, if one speed is much smaller than the other, then its reciprocal, or duration, is much larger, and this dominates the weight in the denominator, which drags down the average speed. It is difficult to make up for the slowest part of the trip. The first expression can be reformulated to give an equation for v2, the descent speed. If we plug in the original numbers to this problem of 20 miles an hour and 40 miles an hour, we get a denominator of 0. Anything divided by 0 is undefined in maths. However, we can say that v2 approaches infinity as v0 approaches 40 miles an hour. So remember that if you find yourself stuck in traffic on the motorway for the first part of your journey, then you would have to approach light speed for the second part in order to make your destination on time. That wraps up the video. Please subscribe to see more like this, and I will see you in the next one.